Okay, we're going to try the Laplace transform again. I tried this just a moment ago and didn't quite get the right answer, so I'm going to try and go through it one more time. So this will be the Laplace transform of the sine alpha t. Alpha is a constant, the variable is time, or t, and the formula that I'm going to be using to solve these two differential equations, I'm going to be doing the Laplace of the sine and a Laplace of the cosine. You can almost solve them both simultaneously, but I'm going to be using this formula here to solve those two. F prime t. So if I start solving for the sine, the Laplace of the sine of alpha t is f0 over s, which is, I'm going to write ls for sine. It equals 0 because sine of 0 equals 0, and then it's plus 1 over s times the Laplace of the derivative. In this case, the derivative is alpha times cosine alpha t, so I'm going to bring out the constant, and I'm going to rewrite this as cosine alpha t. So in order to solve for the Laplace of the sine, we have to know the Laplace of the cosine. So solving for that, we see that it will be equal to f0 over s. Cosine of 0 is always 1, so it's 1 over s. And then we add the derivative, the Laplace of the derivative of this, but we're adding, since the derivative is negative alpha sine alpha t, we're going to be subtracting, and it's alpha over s times the Laplace of the sine function. So all this right here is saying that the Laplace of the sine function is alpha over s times all of this right here. This is 1 over s minus alpha over s Laplace of the sine. So now I'm going to distribute, and we get alpha over s squared minus alpha squared over s squared Laplace of the sine function. Next, I'm going to bring this over to the left hand side, so I get L plus, since we're adding it to both sides, L plus alpha squared over sine squared, L equals alpha over s squared. Okay, now factoring, we get 1 plus alpha squared over s squared. L is alpha over s squared. Combining this into one fraction, we get s squared plus alpha squared over s squared times L is alpha over s squared. Now if I multiply both sides by s squared and divide both sides by s squared plus alpha squared, I get L is equal to alpha over s squared plus a squared. So that's the Laplace of the sine alpha t. So we can actually use this now to go back and solve for the Laplace of the cosine alpha t. And that's, which one is that? That's this one here we're going to use. So that's 1 over s minus alpha over s of the sine. So if we say cosine alpha t is equal to 1 over s minus alpha over s of this right here, which is alpha over s squared plus alpha squared. So combining this all, I'm going to multiply the left side by s squared plus alpha squared divided by s squared minus alpha squared, so that I get in the numerator s squared plus alpha squared, and then I'm subtracting an alpha squared as I distribute this inside. And then on the bottom I'm just left with s squared plus alpha squared. And the alphas cancel out, and all you're left with is s in the numerator. I forgot to, I didn't distribute the s, so there's still an s down here, and that s cancels with one of those in the numerator, and so you're left with s over s squared plus alpha squared is equal to the Laplace, the cosine alpha t.